is this reaction? You take rusty iron, you have aluminum filings, it reacts to form aluminum oxide and iron. Does anyone know the name of this reaction? Thermite reaction. Anyone seen this reaction before? So this is a reaction that was used, for example, to take railroad ties and weld them together. Also a reaction that was used to make certain types of hand grenades that would eat through the iron in tanks. So it's very exothermic. You get a lot of heat in this reaction. In particular, because aluminum and oxygen like to get together. So the aluminum will be able to take away the oxygen from this, what's the name of this? Yeah, you still got to know what it is. So this would be oxygens, this would be iron 3 oxide, right? So what we're going to do is we're going to show you this reaction and how exothermic it is.
Do you want me to take over?
Yeah, go ahead.
Okay.
We didn't have time to make a test this moment. Let's So since the person doing it might die, we'll let Bob try it first.
Gee, thanks, Darren. So anyway, so we have a thermite reaction. What we're going to do.
Do you guys want to go in the first row?
Hopefully it should be okay, but if you want to get that out of the way, that's fine. Oh, there's also one other thing that I did forget. There you go. So now, what I have inside is a mixture of iron oxide and aluminum powder. On the top of it is a layer of potassium permanganate, and what I have in here is glycerol. What I'm going to do is I'm going to put the glycerol onto the potassium permanganate. There's going to be a delay, maybe about 15 seconds or so, but then what's going to happen is that this will initiate the reaction, and hopefully you'll be able to see the effect. But you can see that is an example of an exothermic reaction. And what Darren is going to do now is take out the result.
This is the molten iron that came out. Okay? So that's glowing iron. So it came out as a liquid, and as soon as it hit the sand, it solidified, and you see some molten iron if you guys want to come up and see. But I think we have one. Do we have one more?
Yeah. Oh, we
have one more.
We have one more. Now, the other thing is that you just look at this up when you get another piece of pair of tongue before I.
So, do you remember? Yeah, I like this. Remember back in Chemistry 161, we talked about periodic trends. These tests are on, I'm sure they're going to go off. So we talked about reactivity of alkaline metals, right? Remember that?
So what we have here is an alkali metal. Alkali metals have to be stored under mineral oil because they're very reactive. So what I have here is a chunk of sodium.
Was that sodium?
Excuse me, potassium. Excuse me.
I would put a little bit more, but. So potassium, as you all know, is metal. And what does potassium like to do in chemical reactions? It likes to give up an electron, right? Water likes to gain an electron. So water will gain an electron from potassium. And this is one of the few metals that when you mix with water, let's take a look at what it does. We'll start a fire. So good on a camping trip. Just if you want fire, just add water. Now, what you end up doing is that now this wood is pink. And the reason it's pink is because it has a phenolphthalein indicator in it. So what has happened in terms of the actual chemistry is that potassium mixed with water, liquid, and it formed H2 gas plus KOH. And KOH is what? It's a base. So that the change in color of the indicator is indicative of the chemistry. Do we have anything else?
Do you want one more? Do you want any more demonstrations? Absolutely. Okay.
If not, we'll whatever you have. This is how every chemistry class should end.
Yeah. Yeah. That's what I meant.
So what I have here is a plastic bottle that has a couple of raising rods attached to it. And they're separated by a small gap on the inside. And what I have is a plastic bottle that's corked. It's got a nice little ribbon attached to it also. And what I've done is I've put in a few milliliters of ethanol in there. So now this is a Tesla coil. So what happens is that when I plug this in, this will generate a spark. When I touch the end of the brazing rod on the side over here, what's going to happen is that the electricity will conduct. It will jump the gap in order to form a spark inside the bottle. The spark inside the bottle will ignite the ethanol. And the result is going to be the following. Did you guys like that? Do you want to see that again? That's the spark that you see. So now I got this, it's a little bit bigger now. This is what happens. You like that? You want to see that again? You guys like this stuff, huh? Okay. Do I have a volunteer to set this off? Okay. You're going to do? There you go. Like that? Okay.
Give her a hand.
Do I have one more volunteer? Same thing as usual.
have
That
a
is-
fantastic